everybody. Good morning, everybody.
Hello.
I'm pleased to be back in this city where I've been doing business since 17 years. My first time was in '99, and I have to say the city has tremendously changed since then. And I'm glad to have been a witness of this. And I think recycling is something that in this city is and has become more important and will become more important in the future. When I was the first time here, back in '99, and I was walking on one of the Shanghai markets, to buy some of the nice products at a lower price that you couldn't find in Europe. And I was drinking a bottle of water. I was surprised that when I wanted to throw it away, there was an old man following me, and he actually was seeing that I was going to throw away my bottle, and he asked if he could get it. Of course, I didn't understand what he wanted, but I gave him a bottle, and I saw him put the bottle in a very big bag full of plastic bottles. And I have to say, whilst we in the Western world have a completely different view on China, I was amazed that people here have this notion of recycling. Of course it was because the man could make some money with it. But the notion of recycling, perhaps in this country and in other developing countries in the world, is living more than in our Western world. Today I will not speak about recycling. I will come to that at the end of my presentation. I will speak about the plastic products in the future. And it's going to be important to know what these products are, because if we want to recycle in the future, we have to design our products today in such a way that recycling will be possible. And unfortunately, it's going to become more and more difficult. Just some words, as Bob said in his introduction, SP is a global organization with as mission to support the global plastics industry with knowledge and a network. We are celebrating next year our 75th anniversary, members in 84 countries, activities in 30, more than 40 conferences in a year all over the globe. You can join our society at www.4spe.org and be part of our community, where you will find a lot of technology and innovation news and information on plastics. And I'm going to speak today a little bit about where and how plastics will be used in our age of interaction. Plastic products in the future will increasingly become intelligent and connected. Let me give you a first example. In the first week of January, we had the CES show in Las Vegas. It's the world's biggest show on consumer electronics. And there, one of the products introduced was this flower pot. Now you can say, okay, what's special about this flower pot? This is just a polypropylene injection molded plastic part. Nothing more simple than that. Well, actually it's not. If you look very carefully, you can see here that there is a water reservoir in the pot, and there is a sprinkling system integrated in the flower pot. Now, this flower pot is linked to your smartphone. Parrot has, in the Parrot app, more than 8,000 plants programmed with their need of water. This flower pot measures the humidity of the earth in the flower pot, and it automatically will sprinkle water according to the humidity which is needed based on the plant which is in your pot. And this is all managed by your smartphone. You will be informed on your smartphone when it's time to refill the water reservoir. So you can imagine that this is not only polypropylene. Integrated in this will be conductive polymers, will be some electronics. This is not going to be easy to recycle this pot. And I would like to join in what Larry just said this morning. Convenience, and I call it comfort. We are looking for more and more convenience and more comfort in our lives. This is a beautiful example of comfort. But unfortunately, it will complicate recycling in the next phase. Let's look at some other smart plastics in our households for the future. Up until now, many of us were making a list on paper when we were doing our groceries, but maybe some of you are doing it now on your smartphone. You're not writing it on a piece of paper, but just putting it on your smartphone. Well, soon also this will be open. This, for instance, another product which has been launched at the CES show from LG. You can see it's a simple refrigerator. And you could think, yes, there's a big iPad on the front of the refrigerator. Well, it's not really an iPad. Every time you open your refrigerator, it will take 3 pictures of the inside of your refrigerator. So it means that from everywhere you are, on your smartphone, you will be able to see what's in your refrigerator. So when you do your groceries, you can see, hey, I only have 1 yogurt pot left, I need to buy 6 more. But not only that, it's an intelligent refrigerator. Once you buy it, it doesn't know anything. But once it starts taking pictures, it will remember the products that you are buying, that you are consuming, the frequency in which you are consuming your products, and basically, this refrigerator will make your shopping list after 1 or 2 months. Because it will know what you eat, it will know your preferences, it will even know the brands that you eat. So this will probably be the shopping list of the future. And not only refrigerators. Companies like Tupperware are looking to make intelligent and connected containers. These food containers, for instance, which are capturing the weight of a product. Or these kind of containers which are capturing volume of a product. So if my wife, for instance, says, hey, I want to make a pie, a rice pie for my husband tonight, she will not have to go back home to check if we have enough sugar in our kitchen. No, she will check on her smartphone, she will connect to the sugar pot in our kitchen and see that we only have 123 grams and she needs 250 to make the pie. So these type of plastic products will be connected. It will even go further. Today, we all know, and I'm sure all of you here know that plastics contribute a lot to preserve food. Unfortunately, there's still a lot of food which is being spoiled. And I have to say, I'm traveling a lot, so also from time to time when I get back and I travel with my family, we find in our refrigerator some food which has been spoiled. Well, there are companies now working at intelligent packaging for food, which will tell us when or not it has been spoiled. You can see this carrot, and just like this carrot, every meat, every vegetable has a certain conductivity. Now this conductivity can be measured. And if you look at this graph, you can see that the electrical resistance, which is the red line, and just for the engineers in the room, the electrical resistance is 1 over the conductivity. You can see that basically here there is a change, it's rather stable, the conductivity, and here there's a fall in between the blue and the green line. You can see a fierce drop in conductivity. And it's basically, whether it's meat or this carrot, this is here, the carrot is still in the mature phase. And here it will start to be over mature, and once it's here, it's spoiled. Now some companies are developing plastic packaging with conductive polymers. And if the conductive polymer is using a color-changing pigment, which changes the color at this conductivity, well, we will be able to see at the color of the plastic pot if what's inside is still ripe or whether it is spoiled. So you can say white, fresh fruit, gray, really time to eat, black, too late. So if you go on a trip and you come back and you open your refrigerator and everything is black, too bad. You'll have to go to the store. But also, with the new refrigerator from LG, you will be able to see, oh, things are getting gray, I have to get home to eat it. Also on the CES show, we're looking at communication devices. And the new communication devices, I mean, today there are still a lot of metal used. they are likely to be on a plastic foil. You can see these very foldable, very flexible plastic foils, which are getting increasingly bigger, increasingly higher in resolution. You can see here, no, don't look at the lady, look at the TV screen, which is being folded. And it could be that the smartphone of the future is just a 1 millimeter thick plastic foil, using conductive polymers with some integrated microelectronics, or it could be just a very small foldable or maybe roll-up device, which you take out of your pocket, and even if you're on Times Square in New York, like here, you will be connected to the internet and you will be able to read your newspaper. Of course, on all these products, you can imagine the use of conductive polymers, the use of engineering plastics, are going to complicate the life of the recycler in the future. But again, do we want this? Yes, everybody wants this. But we have to start thinking in the design process that later, in a later stage, these products will be discarded and that we will have to recycle them in the future. Perhaps the next smartphone will not be a phone, but will just be a lens, which projects the emails or which projects Google Maps on our lens and gives us the direction we have to take. The Google glasses were not a success, but I think they came a little bit too early. So maybe in the future, things like these lenses will become very, very common. Another nice introduction at the STASH show was this smart shoe. Of course, made out of 100% rubber and plastic. It ties and it unties automatically. So yes, what we've seen in Back to the Future, Martin McFly with his shoes, they are now coming on the market. So quite often when we look at things like Star Trek, we think it's not possible. Well, many of these things will become possible in the future. It illuminates when it's dark, the shoes. It heats when it's cold. There's a GPS tracker, which is maybe good for you, but not if your wife is connected to it. And it also has a calorie tracker when you are walking. Okay, today we have it on perhaps on our smart watch, but also these kind of products will increasingly come to us in the future. Switching gears a little bit to transportation. In the presentation that I gave at the Plasticity Forum in Portugal, we looked a little bit closer to the car and the full plastic car, which in my opinion is something that will come. At that moment I said that the plastic engine was still not underway. Well, I'm glad to say that the first prototypes of a full plastic engine are being produced, and we're looking at by the use of engineering resins which have very high temperature resistance. Cars in the future will look completely different. They will be driverless, this is sure. This is really sure, they will be driverless. So no need for a steering wheel, no need for the instruments. You will simply say to the car, I want to go to Xinjiang in Shanghai, and it will bring you there. You can read your newspaper. Well, the newspaper will probably be on folded plastic, not on paper. Or just simply with your wife drink a coffee when you are going to work or somewhere else. Also in the cities, urban mobility will be completely different. We will see increasingly more new type of very small vehicles which we will use to displace ourselves. You can see here a prototype which you see on these automotive shows, and then you say, yeah, yes, this is something that will or might come, things like this, but then they are already existing. I mean, this Envy car, which is produced in the US, and you can see the brand here supported by one of the big OEMs. These are things which are almost solely made out of plastic because they are electrical and they have to be lightweight. Urban mobility also in the future will have new infrastructure. There are tests being done in some of the northern European countries to make pedestrian and cycling highways. I mean, today when you say highway, everybody knows it's for the car. Well, I'm sure we will have highways in the future for bikes and pedestrians. Today, one of the big problems in Europe is that we have, of course, the bad weather, just like we had here in Shanghai the last couple of days. It's raining, people take the car. If we have these kind of pedestrian covered highways, covered of course by polycarbonate, we will be able to move into the cities, drive with our bicycles to a subway hub like this one, and then get on the subway and go to our final destination within the city. And even then, we can probably have a foldable bicycle which turns into a bus seat. So no more need of seats into the subway. We arrive with our foldable bicycle, fold it up, and simply sit down on our bicycle. Bicycles could look a little bit different than today, or they could look like this, which are urban mobility devices, as they are being called. Of course, mainly existing out of plastic and rubber. This is another example here called the amplified walker. I really like the name. So these kind of devices will increasingly come to help us and move in the big cities. Let's have a look now at the medical side of plastics. We will use increasingly polymers and plastics also inside our body. I heard the name of Eric Schmidt from Google. He wrote a very interesting book a couple of years ago, looking into the future. One of the things he states, and I believe this will come, is that our body will be implemented with different sensors. One of the professions that might become obsolete in the future is that of the regular doctor. Because with all the sensors, you will be informed, whether it's on your smartphone or on another device, hey Wim, you're getting a cold. It's time to take some medicine. Or hey Wim, your blood values are deviating. You should go and see a specialist. Of course, there will still be doctors, but the doctors will be real specialists to handle the special cases and things like surgery. But the regular doctor probably will be replaced by a lot of sensors which will be implanted in our body. And I don't know if you're familiar with the concept of self-healing polymers. Self-healing polymers are polymers which have still some monomers or some radicals left, which allow, when there is a crack in the polymer, to continue the polymerization and basically repair the crack without us touching it. It's being used today in bridge, composite plastic bridge constructions and in the construction industry. But people are already thinking further. What if we use this inside our body? I mean, blood, for instance, is used mainly to transport oxygen. Now, we have polymers that can transport oxygen. What if we combine this with self-healing polymers which could heal or even have other functionality inside our bodies? I have a small video, but we will not run it because I'm running out of time. And if you have time, check out some of the TED Talks of Dr. Atala. Dr. Atala is a specialist in 3D printing of body parts. Now, there is one of these videos is very interesting because he has produced a bladder of a young boy, enabling the young boy to have a normal life again. And this bladder has been produced with a mix of polymer gel and proteins of the child's body. A protein actually is a polymer, and by copying the protein structure, we can have polymer gels that can be used to print body parts. Already bones, if people replace a bone, we are using polymers. So the use of polymers inside our body is something which will be increasingly used in the future. So having a look at which type of plastics will be used, well, engineering polymers, composite plastics. Look at the aircrafts. Maybe you know this, maybe you don't know this, but the wings and the structures of the aircraft today are completely out of plastic. There is, in the wing of an aircraft, there is not a lot of metal used anymore. The outside of the wings are thermoset plastics with carbon fibers, as is also the structure. These composites are not easy to recycle. the question is also, if we recycle them, can we reuse them to make new wings? I mean, I'm on the plane all the time. I want to be sure if we recycle them that they will be having the right properties. Thermoplastic elastomers, which are sometimes also the TPEs, which are a combination of rubber and thermoplastics. Conductive polymers, which are embedded inside regular thermoplastics. Color-changing plastics. Self-healing polymers. 3D printing. No time to talk about this today, but the polymers used for 3D printing are also completely different than the polymers that we know, like polyethylene and polypropylene. So it means that the mix of plastics in the future is going to be very, very versatile, very, very diverse. And this is something which, for us also in the recycling industry, we have to think of. So it is going to be very important. And I hope that an organization like mine, like SP, can really help with that. You know, our engineers, if they can make something more complex, they will do it. If they can make something more integrated, they will do it. But we have to remember that they have to design for recycling. If we cannot have our industry convinced at this very original source, yes, we need innovation, but please design for recycling. It will be an increasing problem. The water bottle is perhaps a very simple problem to solve, although there are a lot of inconveniences. But what if all our plastic products are integrated, metal, different polymers? It's going to complicate things. So we have to make sure that our industry is having the reflex to think that this will be important for the future. So unfortunately, convenience or comfort today comes before sustainability, and we need to make sure that we can inverse this sentence. So having said this, I think that plastics and polymers will and are for sure the material for the next couple of decades. They will bring a lot of new products, and I hope also with this that we will be able to recycle much more of the products and have a much more sustainable or plasticity world. And therefore it's really good that we have these kind of conferences to remind us and to make us think deeper that recycling is the way for the future. Thank you very much.
We talk about the importance of design for recycling, and for me it seems there needs to be some kind of incentivization for one to do that kind of design process. Now that can come through people being considerate and wanting to retain their products, so they're very complex, but in terms of the product, the concept of extended producer responsibility, whereby you try and internalize the negative externalities of the end-of-life process. How realistic do you think that is for, say, top-down governments to impose those on producers without being accused of stifling innovation and preventing all the positives that can come from these complex polymers?
To be honest, I think this is, one of the things, and I managed a couple of companies, what you want to do with your innovators in your company is let them think outside of the box. I mean, not limit them. As soon as you start limiting an engineer, he starts to shake. I mean, especially the innovators in our world, which bring these fantastic new products. You have to let them loose. If you really limit them, we will miss a lot of good things. And let's also not forget that there are always several sides on sustainability. Let's take the example of the aircraft wing. Yes, it is difficult to recycle because it has carbon fibers inside the plastic, polyester or thermoset material. But let's not forget that thanks to the use of these carbon fiber plastics, the weight of the aircrafts today is 20 to 30% lower, and thus the consumption of fuel of the aircrafts is much, much lower, which has a much bigger impact on our CO2 emissions and things like that than the recycling problem of the aircraft wing itself. So if we would have limited the engineer to make this product, we would probably have missed the saving, the much bigger saving on CO2. So I wouldn't ask the countries or the governments to limit that. I would only, and it's the industry and the governments who say, please think about when you design a product. Yes, we need innovation, but think about it. If you can make it as a design for recyclability, please do it. But I would not ask the governments to really limit the companies to it. Thank you. Enjoy the rest of the day.